On April 19, 2021, the first powered flight on another planet was executed by the NASA Mars helicopter. This was an incredible achievement, especially because the mission almost failed several times. But the real surprise for scientists and engineers at NASA came much later in the mission, as they dealt with unexpected conditions, revealing an opportunity that nobody could have anticipated. In 2012, the director of the NASA Jet Propulsion Laboratory, or JPL in short, visited different labs. In one of the labs, they were using drones to demonstrate navigation algorithms. When JPL director Charles Elachi saw those drones, he asked, "Hey, why don't we do that on Mars?" And now, the ultimate goal of flying a helicopter on Mars was born. The Jet Propulsion Laboratory is part of NASA and responsible for robotic spacecraft, such as Voyager 1 and 2, the Juno spacecraft, and the Mars rover Curiosity. JPL worked together with the company AeroVironment to build a 1/3 scale model of a helicopter that's gonna fly on Mars. This helicopter would be attached to the bottom of a Mars rover in the future. Testing with the scale model went relatively smoothly. First, they tested the helicopter attached to a vertical rail inside a vacuum chamber, representing the Martian atmosphere. After this went okay, they removed the rail and it freely flew in the vacuum chamber. In January of 2015, the team got more money from NASA to spend on a full-size vehicle after these successful tests. Meanwhile, NASA was busy with the big upcoming 2020 Mars mission. They would launch a rover, later known as Perseverance, to Mars. The rover would investigate the Martian ground to look for life. The team working on the Mars helicopter were hoping they could attach and integrate their helicopter underneath this rover so they can launch it to Mars. But leaders at NASA hadn't decided anything yet, so until then they could only hope. One of the challenges this helicopter had to overcome is the low-density atmosphere on Mars. The atmosphere on Mars is about 1% as dense as the Earth's atmosphere at sea level. You can compare this with flying at a height of 27,000 meters in the Earth's atmosphere. The problem is, this altitude can't be reached by existing helicopters because you need to generate a huge amount of lift. To overcome this problem with a Mars helicopter, the team at JPL designed two blades made out of carbon fiber. These 1.2 meter long blades only weigh 35 grams each, but can spin 40 times per second. This is 10 times faster compared to what's needed on Earth. Another hurdle the helicopter had to overcome was the time delay. Radio signals take 5 to 20 minutes to reach Mars. Therefore, we humans cannot control the helicopter in real time. The solution is to make the helicopter fly autonomously with the help of two cameras and different sensors. Together with the low-density atmosphere, this was a big challenge to overcome. At the end of 2017, they were done testing. But even though these tests went successful, NASA did not yet include or spend the money on the integration of the Mars helicopter in the 2020 Mars mission. This meant the JPL team spent 5 years developing and testing a helicopter for Mars, but they were still a long way from actually flying on Mars. If the helicopter would be successfully launched to Mars, it could improve the rover's mission. The helicopter would scout for the Mars rover to check if certain routes actually were achievable and not too rocky, for example. This would be a great improvement instead of only looking at satellite views. In addition, the helicopter could also look for new interesting places for the rover to research. But only showing that flying on Mars is possible would already be revolutionary. However, the science team from the rover didn't want to add the helicopter, because they thought it was going to be a distraction from the task the rover needed to accomplish. To make things worse, a lot of engineers and managers at NASA also did not like the idea to add a helicopter to the rover for a flying demonstration on Mars. For example, the project manager of the 2020 Mars mission, Ken Farley, said this: "I am not an advocate for the helicopter. and I don't believe the Mars 2020 project has been an advocate for the helicopter. This comes right out of science time. I've personally been opposed to it because we are working very hard for efficiencies, and spending 30 days working on a technology demonstration does not further those goals directly from the science point of view. May 11, 2018, NASA announced that a helicopter could be developed and tested in time to be included in the Mars 2020 mission. After 6 years of development on the Mars rover, it suddenly had to accommodate a Mars helicopter. The helicopter did more intensive testing, and 1 year later it was mounted to the underside of Perseverance, the name of the rover. The helicopter got also a name. From now on it was called Ingenuity. On February 18, 2021, Perseverance with Ingenuity landed on Mars.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Ingenuity was finally about to begin its 30-day demonstration. At this point, no one knew what to expect from the first ever Mars helicopter. Before the first flight, multiple objectives had to be checked off. Confirming Perseverance dropped the shielding protecting Ingenuity. Check. Confirming Ingenuity has been deployed from the rover. Check. Confirming cameras took their first picture. Check. Confirming that the rotor blades are unlocked. Check. Confirming a low-speed spin test of the blades. Check. Confirming a high-speed spin test of the blades. Failed. A timer expired too early and caused a problem in the transition from pre-flight mode to flight mode. Luckily, the helicopter itself was fine. JPL decided to slightly change the timing of the command sequence. From prior testing, they knew it would have an 85% chance of succeeding. April 19, 2021, after 9 years of development, the first powered flight on another planet was a fact. Ingenuity hovered 3 meters for about 40 seconds in the Martian air. While this was a great success, the next flights would be increasingly ambitious. But the years of hard work and research paid off. Ingenuity completed the second and third flight without any trouble. NASA decided to move on from only proving that flight was possible to an actual operations demonstration. This was because the Perseverance rover was ahead of schedule and Ingenuity was performing beyond expectations. This meant the rover's schedule wouldn't be impacted significantly by Ingenuity. It's now August 2023 and Ingenuity has made 52 flights and it is still operational. That's 10 times more flights than originally planned. It has a flight time of 1 hour and 34 minutes if you combine all the flights, and it has traveled more than 12 kilometers in the Martian air. Oliver Toupé, one of the drivers of the rover at NASA, said, "The team wanted to drive Perseverance over a hill, but after flying Ingenuity over the hill, they saw it was too rocky and decided to drive around it." He also said, initially there was a lot of pushback, even from the science team, because they thought it was going to be a distraction. But in the end, we were all very happy with the helicopter, including the science team. Ingenuity's achievements cannot be overstated, and it will be remembered as one of the greatest pioneering vessels of all time. One day, Ingenuity will make its last flight on the Red Planet, but it will not be the last aircraft to fly on Mars. It's just the beginning.